Hello, welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we continue talking about networking, but we're going to switch from standard socketing to RMI, or remote method invocation. Now at a fundamental level, all networking is being done through sockets. RMI just wraps things up and gives us a higher level of library, and gives us the ability to do exactly what the name implies. It allows us to invoke or call methods remotely, so that you can have a reference to an object that's actually on another machine and call the methods on it, instead of having to, with our sockets, you had basically one set of sockets between your programs and you could send messages. But as your program started to get bigger, you'd run into challenges where the instructions that you're sending, you have multiple types of messages. Each side has to figure out what the message is, what it means, and where it's supposed to go in the program, and it starts to get a little bit problematic. RMI deals with a lot of those details for you. Now, of course, like everything else, you get something and you give something up. In the case of RMI, there's a bit more of a startup cost, in the sense that your smallest RMI program is going to be a little bit more elaborate than your smallest socketing program. But the bigger challenge that you have with RMI is that this is fundamentally a Java library, and as a result you're only going to be able to use RMI between programs that work on the Java virtual machine. So our Scala programs that run under the JVM, they're perfectly fine. But whereas our socketing, we were able to talk to a very simple program like Telnet, RMI we won't be able to interface with Telnet or most other programs that you might write in a C or C++ or Python, unless perhaps maybe you can get Jython to support it. So we're limited as far as our scope there. But for a lot of applications that we want to write, if we're going to write both the client and the server in Scala and in Java, RMI can make our lives a lot easier. So we can look in the API, and you see there is a package called java.rmi. It also has several sub-packages under it. And inside of the RMI package, there's this interface called remote, a few classes, and a bunch of exceptions. As with networking, as with the regular networking, all types of things can go wrong when you start using RMI. So this remote interface is going to be very significant to us here. It turns out that, so if I want to write an RMI program, I need to go through a few steps to get things set up. Like I said, that was one of the costs that we have here. So what are those steps? Well, the first thing that we have to do is we're going to need to write what's referred to as the remote interface. Now in Java, it would actually be a construct called an interface. In Scala, it's actually going to be a trait. Now I'm going to go ahead and, at least for this first example, I'm going to put everything inside of one file. So I'm going to make a file called RMI chat. I'll go ahead and put a main in my object, and I'm going to put everything inside of here. Now this really isn't the ideal way to structure things. We should break things across files, but I think it will be easier for you to see what's going on with this first example if I put everything in one file. And then we will, for our next example, which will be larger, we'll start to break it up. So the first thing I have to do is I have to create a trait. And how about I call this remote chat? Okay. This is the interface. This has the methods in it that we can call remotely. And when we do this, it has to extend that remote interface from the API. Now if we jump back over to the API and we look at this interface, one of the things you'll see is there are no methods in this interface. So we aren't really required to add any code. This is more a signal to the Java virtual machine that something of this type should be connected to remotely. And we'll come back to talk about that in just a bit. So our first step is to write this remote interface and give it whatever methods we're supposed to have. So maybe if this were, for example, this is the client side of things. Receive message. So it'll receive a string, and we'll make it so this returns unit. And then how about we have another method for new user? Maybe we can make this, we'll put it inside of a GUI. As I said earlier, we can't use Telnet because this is RMI. We could have it so that it sends back and forth new users, and you keep a list of all the users that are logged on. And also will return unit. Now, this has to be completely abstract, and this is because it needs to compile to a Java interface. So I cannot put definitions on any of these methods in here. I cannot put any data members inside of here with definitions. So I have to leave everything completely abstract inside of this trait for it to work. The other thing that I have to do is I have to signify to the environment that this can throw an exception, and in particular it needs to say that it has the ability to throw a remote exception. All types of things fit under the header of remote exception, almost anything that goes wrong. And so to do that, I put an annotation. I'm going to use the throws annotation, and if we come over and we look in the API, we have the throws annotation, and when we create one of these, we're supposed to pass it the class of the type that it can throw. So I'm going to say throws, and then inside of parentheses I'm going to give it the argument, and my argument will be class of remote exception. And I'll copy that and paste it down here. If I put an underscore there, it will automatically import that. And this was step one. Okay, now I have an interface. We might also want an interface for the server side. And it also needs to extend remote. And then we'd need to put our methods in here. So this would be someone logs in. We're going to give them the name. And let's see. When you log in, I want to do that. I also want to pass in the client, which is one of these, the remote chat. And I want this to return, okay, I've already gotten hold of it. We'll return unit at this point. No, actually, let's return a list. How about an array? Array of remote chat. This is a list of all the users that are currently logged in. Another thing that we should be able to do here is to send the message. And at least for now, I won't keep putting information. Well, no, okay. I'm just going to make it so it sends the message like that. We could make it so it also passes in the client who is sending it, so we'd have some additional information, but I'm not going to worry about that. And the real benefit of RMI is the fact that I can very easily add new methods onto this. And maybe as we go along, we'll see that we have other methods that we want to put into here. So this was step one, build the remote interfaces. Step number two, write implementations of these interfaces. So, and how about I put the remote chats interface or implementation in here. A standard way of naming these things is to take the normal name and follow it with impl. Now, these have to extend the interface that we wrote. Okay. They also need to extend another type from the RMI library, and it turns out that in this case you have several options. So these are under the RMI server type. There are a number of different types that you can extend. By default, I typically used a unicast remote object. So once again, so this has a number of methods in it that are needed for anything that is going to be remote. We don't have to write them. They're there for us in the class. So I want this to extend a unicast remote object with remote chat. And if we do our imports, there we go. like I'm waiting for the error to pop up. This has an error because I have to implement both of these methods inside of here. We can decide exactly how we want to go about doing this. What each of those should do, but that at least gets it so that it compiles. The receiving the message should probably add something, either if we just had it so it printed to screen, I guess the simplest implementation for this would be print line message and print line name has arrived. Okay. So those would be some very simple implementations of the chat that just use the console environment. We could write one that uses a GUI as well if we were interested in doing so, but I really don't want to take the time to do that for this video. We would also want to do the exact same thing for the server. I'm going to write a class unicast remote object with remote chat server. Now I can add more methods into these if I want, okay? But the only ones that I can call remotely, the only ones I can call from another computer, are going to be the ones that are, I'm realizing that I probably want to create one more file, another object with a main. We'll call it RMI chat server, and I'm going to go ahead and move my server code into there, and then we'll think about things a little bit. Okay, I need to have implementations on these here. So Control-Shift-O, that imports everything that we needed. No, not a good implementation, but it's an implementation. Okay, so this was step number 2. Step number 1 was you write your remote interface, which contains all the methods that you need, that you want to be able to call remotely. Step 2 was you write an implementation. It has to include those methods, but it can also include whatever other methods you want, but the other methods will only be callable locally. This version up here needs to extend remote, and each of the methods needs to say that they throw a remote exception. This here needs to extend a unicast remote object with the interface that we wrote originally. Now, once we have this inside of our server code, the first thing we need to do inside of here, or one of the first things we need to do, is we need to create an instance of this and bind it to our RMI registry. So the binding to the RMI registry is done inside of Java RMI. There's this class called naming. And naming has methods for binding, for looking things up, and for rebinding. Looking things up is the next step. I generally call rebind. So bind will bind it if the name isn't being used yet and throw an error if the name is being used. Most of the time when I'm doing this, if I wind up there's a name already being used, it's probably an old run and I want to get rid of it, so I will generally use a rebind instead, which doesn't give you the error if there's already something there. Obviously, if you have the chance that you might not do that, that you might want to be informed when something's already there, just use regular bind. So I'm going to make a new RMI chat server impl. Okay. Not found type. Remote, not RMI. remote chat server impl, okay, and then I'm going to use naming.rebind. And if we look here again, what methods do we, or what do we pass to rebind? We pass the name that we want the object to be known by and the remote. And so the name needs to be in a URL format that specifies where you find these things. So the format here is generally //host and the port and the name. If you leave off the full specification, it will bind it on the current machine. So the object I want is the one we just created for server, and I'm going to use the name RMI chat server. Now the reason that we need a name is because of the next step, which is that this needs to look it up. So when a client wants to start running, it needs to find a server to connect to and then do the login. So the whole RMI server is really so that you can do that initial lookup thing. Because from that point on, you're just going to call methods on stuff, and these methods can return to you remote objects. For example, as we already said, this is returning a bunch of remote chats. So if we come over here, just very quickly, naming dot, let's make this a val server equals naming dot lookup of, and the lookup method takes a string for the name, and once again this should be in that long format. Generally we can say it's in, and the RMI is optional, as I said, because this is all happening through RMI, but just to make it clear, this is using the RMI communication style, and right now I'm only running on the local machine, and we called the object that we're looking up this. Now there is another piece of the specification that's up here. You can put a colon and a port number. By default, the RMI registry is open at 1099, and that is where everything is going to be looked for. So I'm just going with the default, but you can specify other port numbers if you want. So this will look it up, and it gives us back a server. Now you'll note something that's somewhat problematic here is this is known as a java.rmi remote. Okay? That's because that's what lookup returns. It returns a remote. We have the library has no way of knowing that we are specifically going to get back a remote chat server. And note that this is the type you will get, not the implementation. But I happen to believe that this should be a remote chat server, so I'm going to go ahead and put this inside of a try-catch block. So I'm going to, or sorry, not a try-catch, I'm going to put this inside of a match. So there is one case where my server is a remote chat server, and in that case I just want that. If it is anything that is not a remote chat server, I'm going to throw an exception, and I'm good with just a remote exception. And let's go ahead and print out, I guess we should give this a name. Okay, so now server has the type of remote chat server, because this case returns a remote chat server, and this case with the throw returns nothing, literally the Scala type nothing. So the mutual super type here is the remote chat server. The last step that we need is, in order for this to actually run, which we're not going to quite get to in this video, we need to have an RMI registry running. Now you can do this from the command line if you want. It is possible to run an RMI registry. It would be part of your Java install. The challenge of this is that you need to be in the right directory, or you can specify the class path. There are various options, but it turns out there is a way to do this that makes your life a bit easier. And this is, if you go into java.rmi.registry, there is one class here called locate registry, and it has a static method on it called create registry, where you give it a port. So at least what I have found is that the easiest way to get your RMI registry up and running is when you create your server. Before you create your server, you can run the locate registry, create registry. And see if that imports. Dot create registry, and as I said earlier, the default port for this is 1099. So this will create an RMI registry that is running here on this local machine on this port. The rebind will bind this object to it, and then the chat can go and look it up. I guess theoretically I can make sure that this actually runs. So my server is running. And now my client is running, and everything wound up terminating because we didn't have them do anything after they looked each other up, but that was a demonstration of we got that far. So we're going to come back in the next video. We'll work a little bit more on this, possibly finish it off, get it so that we can actually do a little bit of chatting between two users. I also want to talk about the passing semantics of what it means when you pass things in and return things from remote methods, because there are some details in this that are worth talking about.